probability. Alright, so that's one of those problems. Let's look at another. Alright, the next one looks like a problem we've done before, but before we had it with one sample, this is two. Alright, a firm has a problem with the proportion of chargebacks that occur on online credit card sales. Of a random sample of 1,000 online credit card sales, 10 involved a chargeback. Alright, the firm then instituted a new procedure in an attempt to reduce the proportion of chargebacks. With the new procedure, the random sample of 400 sales resulted in 2 chargebacks. If the true proportion of chargebacks remained unchanged at 0.9%, what is the probability of getting a decrease this large or larger? Okay, again, 2 samples. Since we're talking about a decrease, that's a direction in one tail, not 2 tails. It's not change, it's a change in a particular direction. A decrease is, so it's one tail. And so again, students will find it more intuitive to put the larger sample proportion first. Alright, so we have 2 samples, first sample size of 1,000, 10 there. What's that? 0.1%. And then in 2 out of 400 is smaller. Alright, so we'll put the first sample first, etc. So N1 is 1,000. That's sort of the before case. After, and N2 of 400. Alright, before the changes, we had chargebacks at a rate of 10 in 1,000. That's 1 in 100. It's 0.01. Now they have 2 in 400. Alright, I believe that'll be 0.5%. Okay. So limit will be the difference in the 2 given sample proportions, 0.01 minus 0.005. Alright, and again that the answer to that 0.005 was a proportion of getting a decrease this large or larger if what? The mean, the true proportion remained unchanged at 0.09%. Unchanged, of course, means this difference is 0, and standard deviation sequence of p hat 1 minus p hat 2 will calculate. Alright, p1 times 1 minus p1 on n1 plus p2 times 1 minus p2 on n2, square root of that whole thing. Alright, so 0.009 times its complement, which will be what? 0.991, divided by the sample size of 1,000, plus, and then the second one, top line, numerator is the same, divided by n2 of 400, and take the square root of that whole thing. So go to Excel, figure that out. Alright, square root of 0.009 times its complement, 0.991 divided by 1,000, sample size there, plus 0.009 times 0.991 divided by the sample size there into 400. And to 4 significant figures, that's 0.05587. Alright, and so we have limit, mean, and standard deviation. And now we can do our normal distribution. Alright, so this is distribution of sample differences. The mean of that distribution, like it is for most, is 0. Alright, limit 0.005. The probability of this is a decrease. The 0.005 was the probability of getting a decrease this large or larger. So yet again, area in the tail. Alright, find the z-value corresponding to that limit, and we'll go to town. Okay, so z, right, is p hat 1 minus p hat 2, the limit, minus the mean of the distribution, p1 minus p2, divided by the standard deviation, sigma sub p hat 1 minus p hat 2. Alright, so the limit 0.005 minus the mean 0 divided by the standard deviation of, and I've forgotten, 0.05587. And we'll do that in Excel. So equals the limit 0.005 divided by standard deviation. Right, the minus 0 just falls away. It's unimportant. And to two significant places, two decimal places, that's 0.89. Alright, and so we're going to find the probability of getting z greater than 0.89. Yet again, area of the tail, so it's a half minus the area in our tables from 0 to 0.89. Okay, and to 0.89 will be that value there, 0.3133. Let's check myself. Okay, and so the answer to that, doing it quickly in my head, should be something like 0.1867. Okay, so the probability of getting a decrease in the chargebacks, if there was no change, is about 18-19%. So it would seem that there has really been no change there. But anyway, that's that problem in terms of calculations, and that's the end of this video.